Hi everyone. Notes 1.3 are on the distributive property, and just a quick note, the video is going to start to say notes 2.2 here, but it's the exact same video, it's the exact same note, so you're watching the right thing.
So the first thing that we see here is a reminder, and that is that when you multiply monomials, you must always add exponents. Always, always, always. So for example, if I have x to the power of 3 times x to the power of 4, that would be x to the power of 7 because we've got 3x's multiplied together here and 4x's multiplied together here. So we've got 7x's multiplied all together. All right, cool. So when you distribute, you must multiply the number on the outside of the parentheses by each or every number on the inside of the parentheses. So in our first example right here, we're going to talk about how we would do this, but I also want to just talk about the fact that what this is saying is we've got two sets of x plus 8. So we've got x plus 8 plus another x plus 8. So if I put these together, x's right here together give me 2x, and these 8's together would give me 16, positive 16. So we would get 2x plus 16. Now, what's the shortcut? How can we do this? Because if I have like 10 times x plus 8, I don't want to write this out 10 times. So all I have to do is distribute or multiply that 2 through. So 2 to the x gives us 2x. 2 times 8 gives us positive 16. So that's what we'll write down right here. Okay, but for number 2, when I distribute the c through here, a very common mistake is we'll see that it is c. And the reason why is because they just see c's here and they'll just write c down. But this is c to the power of 1 and c to the power of 1. And when we multiply, we have to add our exponents. So this would be c to the power of 2. Then we do c to the 4, so we get 4c. So this right here is my answer right here. Now, if these were not like terms to begin with, then these should not be like terms at the end. So see here, for example, when I look at this c plus 4, there's nothing in common with c and 4. So we can't put them together. There's no like terms, then we shouldn't have like terms here. Okay, in number 3, same idea. I want to multiply 3d by 7d. So 3 times 7 is 21, and this is d to the power of 1 and d to the power of 1, so we get d to the power of 2. Then we're going to multiply the 3d to the 2. So 3 times 2 is positive 6, and then there's a d here, so it's plus 6d. There were no like terms initially, so there should be no like terms at the end. If we have like terms, then we need to fix something. Something went wrong. Okay, so same thing. Let's look at number 4. I'm going to take the 3a and I'm going to multiply it to 2a squared. So 3 times 2 is 6, and a to the power of 1 times a to the power of 2. When we multiply, we add our exponents. So we've got a to the power of 3. And again, that's because this is saying 3 times a. This is saying 2 times a times a. So 3 times 2 is 6. A times a times a is a to the power of 3. And then we're also going to multiply this 3a to the 7ab. Now be really careful about this. So 3 times 7 is 21. Since it's a positive 21, we'll write plus 21. And then we've got a to the power of 1 times a to the power of 1, so we get a to the power of 2. And then we still have this b here, so we want to include this b here. So this is the answer that we would end up getting here. Okay, in number 5, I'm going to multiply the 13x to the power of 4 to each one of these right here. So 13 times 2 is 26. And then I've got x to the power of 4 times x to the power of 7. What would that give me? Think about that for a second. Write down what you think it would be. Hopefully you said x to the power of 11 because 4 plus 7 is 11. Then I'm going to multiply 13x to the power of 4 times 3. So 13 times 3 is 39. But because there's an x to the power of 4 right here, I can't lose it. I can't drop it. So we still have x to the power of 4 here. It does not become x to the power of 5 because there's no x to the power of 1 here. There's no x's at all. So if there's no x's here and 4 here, then we have 4 x's being multiplied together for this right here. Okay, and number 6, this time I have to distribute that 9j through 3 times, okay? And how do I know it's 3 times? Because there are 3 different terms here. So I'm going to take the 9j and multiply it by negative 3j squared. Now remember, this is j to the power of 1. So 9 times negative 3 is negative 27, and then j to the power of 1 times j to the power of 2 is j to the power of 3 because we add our exponents. Next one that we see here is 9j times positive 2j. So 9 times 2 is positive 18. We'll write down 18. We'll write down plus 18 because it's a positive 18. Now, since this is j to the power of 1 and another j to the power of 1, that means altogether I've got j to the power of 2. And then lastly, I'm going to see here 9j times negative 7. Well, 9 times negative 7 is a negative 63, so we'll write minus 63 down. And then we still have this j here, so we'll write this j like this. And this is my final answer for number 6. Number 7 is a tricky one, so pay really close attention to this. So in number 7, I'm going to distribute this negative 2 through to the x. So negative 2 times x is negative 2x. I'm also going to distribute the negative 2 through to positive y. So negative 2 times positive 1y is negative 2y. Now I'm not going to distribute the negative 2 through any further because the bracket has closed. So there's no more distributing for me to do here. Now I need to do the same thing with this negative 5. And it is a negative 5 because it has a minus sign here. So we have to remember that it is a negative. So negative 5 times 3x is negative 15x. And then negative 5 times negative 2y, a negative times a negative is a positive. So this should be a positive, and then 5 times 2 is 10. So I've got 10y. Well, now that I've done that, because I have two sets of distributing here, I actually end up getting to a point where I will have to collect or combine like terms. So if you see here, this is negative 2x. Are there any other terms with x's on them? Right here, we've got negative 15x. So when I put negative 2x and negative 15x together, I get negative 17x. And I also have this negative 2y and this positive 10y. So negative 2y plus 10y, when I put those two together, let's do the scoreboard for that. So negative 2 plus 10, team negative won the 2 points, team positive won the 10 points, so team positive won by 8 points, so this is 8y. Now this negative 17x and this 8y have different variables, so they're not like terms, so I am done with this question right here. Okay, and number 8, this is another tricky one. So when we distribute, we want to distribute from the inside out. So we actually have multiple distributing here. So what do I mean by that? Do you see this 3 that needs to get distributed? That's on the outside. So we're going to start from the inside, and we have this negative 5 here that needs to get distributed first. So I'm going to do negative 5 times 2x, which is negative 10x. Then I'm going to do negative 5 times 1, which is negative 5. Then I'm going to copy everything else down exactly how I see it. So I'm going to copy down the 4, the brackets, and the 3 here. Now, this set of brackets here, these square brackets, are the same thing as these round brackets. We just have these square brackets to kind of differentiate the fact that we have two sets of brackets here. But if you don't like the square brackets and you want to use round ones, go for it. Okay, so now we've got a couple options here. We can either continue to distribute here. So if I were to continue to distribute, this is what it would look like. I would take this 3 on the outside, multiply it by 4, I would get 12. Then I can take the 3, multiply it by negative 10x, and I would get negative 30x. Then I take the 3, multiply it by negative 5, and I would get negative 15. But at this point in time, I still see that I have like terms. So I've got 12 and negative 15. So team positive won the 12 points, team negative won the 15 points, team negative won the game by 3 points. So we would say that this is negative 3, but then I would copy down the negative 30x. So this would become negative 30x minus 3. Now, another option that you have is you can actually collect your like terms inside the brackets first. So for example, right here, I've got this negative 10x, nothing is like it, so I'm just going to copy that down. Then I've got 4 and negative 5. So team negative won the 4. So team positive won the 4 points, team negative won the 5 points, so team negative won by 1 point. Now I can go ahead and distribute that 3 through. So 3 times negative 10x is negative 30x. 3 times negative 1 is minus 3. And so this right here is what my answer would be here. And the last question that I'd like to talk to you about in this video for right now is number 9. So it says if the length of a rectangle is 5L squared, so I'm going to highlight that because that's really important information, okay? And the width of a rectangle is 7L plus 2. What is the area of the rectangle? So just a reminder, area is equal to length times width. And here we know our length is 5L squared. And we know our width is 7L plus 2. But here's the thing, because this 7L plus 2 represents the entire width, we absolutely positively have to have brackets around the 7L plus 2 in order for us to make sure that we're multiplying this 5L squared to the entire width, which is why we would have to distribute here. So when I multiply 5L squared by 7L, 5 times 7 is 35, and then L to the power of 2 times L to the power of 1 is L to the power of 3. Then I do 5L squared times 2, which is 10. Don't forget that there's an L squared here, so it's 10L squared. So this is my answer in terms of L. And that's it for this video. We'll talk about 10 and 11 next time we see you in class. And let me know if you have any questions. All right, have a good one. Bye.